Okay, this is now recording. I forgot to press on record button. So again, going back, by just looking at the graph, guys, you would tell, or we can tell, that the function is increasing because it goes up to the right. Now, when we want to make a definition in mathematics, guys, we have to be like specific when it comes to our definition. In other words, we are going to make a counterexample. Accept. Pa-accept daw si, who's Yula?
That's one of our classmates, sir. Sophie.
Okay. Okay. Sir, the screen is really blurry. Is it, are you, guys, how do you see the screen?
It's okay on my end, sir.
Na yung mag-black-black, no? Ang the black-black ba, does it like kanang distract you for the entire? Okay. The reason mag ng black-black good is that when I share my screen, I choose the option nga optimize video for clip para sa recording kay dili maglaglag. But anyway, let's just remove it na lang. Kana, do you see the black-black na? Wala na, no? I think so, wala na. Okay. Okay. So going back, again, this is an increasing function, but just looking at it because we know it's going up to the right. However, in math, guys, when we define something, we need to be specific. With that being said, I'm going to pick a point. Let's say, for example, somewhere here and this point somewhere here. This is x of 1. Let's say, for example, that's x of 2. Because we don't know the actual number, so let's just make a general term for them. Now, with that being said, this follows that this point here has a function value of f of x sub 1. Tama? Also, this one here, kani siya nga point, has a function value of f of x sub 2. No. By just looking at this situation here, guys, we can make a definition out of this situation here. How? We can tell nga a function f is said to be increasing. So a function is said, I'm making now a definition, I'm writing a definition of an increasing function, is said to be increasing, excuse me, if x sub 1 is less than x sub 2. Do you understand ganong less than? Take a look at these values here. These values, the x sub 1 and x sub 2. Which one is greater? The x sub 1 or x sub 2? It clearly shows that the greater value is x sub 2. Agree? And then the lesser value is x sub 1. So that's going to be, a function is said to be increasing if x sub 1 is less than x sub 2, then these two things here can be compared using f of x sub 1, sorry, nagawas ang 1, is also less than f of x sub 2. Does it make sense sa definition? Wala question sa definition? Sige. I'm going to draw another type of function that is going to be decreasing. This time, I want you to make a definition similar to this, but you're going to make twists. It's not going to be all the same, but you have to change something. So we're going to pick a point, and we're going to pick a point here as well. This is x sub 1 and x sub 2 here. Okay? And then you can type your answer now, guys. And then you can move here. You have your f of x sub 1. And then this one here is your f of x sub 2. There. So this is a decreasing function. The second graph that I just showed you guys is an example of decreasing function. I want you to like create a definition similar to this, but you have to make changes on some part of this definition here that would fit sa kaning illustration. What do you think? You can unmute or you can You can type your answer. If a function or if okay, there's actually something wrong with that, Kian. You said x sub 1 is greater than x sub 2. So let's try to focus on that. Okay. Wait daw. Okay. Sige. I think she's modifying the definition. Party girls. So how about the other guys? You have guys answers? No? Okay. Gian, your answer is almost okay. Your answer is already almost correct.
I didn't care how to complete it, pero ang fx of 1 or y1 is greater than y2.
Yes, that's actually correct. But your first or your what do you call this the premise or the hypothesis, which is the x sub 1 greater than x sub 2 is somehow
Wow.
yes. Take a
Yeah,
look at this one here. This one here. If we're going to focus yourself sa kanya values, which one is bigger?
still x of sub 2, sir.
Very good. It's still x sub 2, so it should be the same thing on here.
Sir.
But the twist is we're gonna be interchanging these two things here.
Yeah.
So
Oh,
if we're
okay.
going to make a definition, a function is, let me just scroll a little bit, is said to be decrease. Inani may maghimo og definition sa math, guys, katong if katugong mag-major og math. From the illustration, we are going to make conclusions or definition. It's said to be decreasing if x sub 1 still less than x sub 2, then this time it's f of x sub 2 is less than f of x sub 1. So the comparison here now is kanina siya. If you notice which one is bigger, of course, kapag yung value nga naa sa higher than the other, f of x sub 1 is higher than f of x sub 2. So it follows nga f of x sub 1 is greater than f of x sub 2. So this is how we define a concept of increasing and decreasing function. The problem here, guys, is that you are provided a graph, okay? So what if you are going to have a function? We don't have a graph. So do we need to graph the function first and then determine if that function is decreasing or increasing? Technically, yes. However, there's a shorter way. The problem I'm good in that process, guys, is that you are going to assume values of x randomly, -3, -2, -1, negative, 0, 1, 2, 3, and then you substitute these values of x into your function, solving for y value. So technically, you have an ordered pair now, or set of ordered pairs. You're going to plot these ordered pairs on the Cartesian plane and connect them. After connecting them, that's when the time that you can tell, okay, the behavior of the function is increasing. And imagine if you're going to have that in the examination, one item maybe it'll take you 5 minutes to answer. What if there are 20 items? Then 5 minutes each item. So murag if you're not only mo siya guys, kuwang ra imuhang time to solve if you're doing the graphical method, right? Katong yung junior high school nga math graphing way of function, like katong mag-set mo og table of values and then and so on and so forth. In calculus, guys, there is a shorter way to do it. Okay. Um, let me write a definition sa ha. Oh, I think mas better kung example diretso rather than a definition. Sige. Let's have an example. F of x equals x squared plus 2x. Tell me if this function is this increasing or decreasing over the interval -3, -1, and Kana lang sad usa lang sa interval so usa lang sa nato. So, x squared plus 2x, is this increasing or decreasing over the interval -3, -1? So the question here is that increasing or decreasing? Your answer should be either yes, it is increasing, or no, it is not increasing or decreasing. So unsa man ni siya guys, we don't have the graph man compared aning na sa previous example with our definition, we can really tell nga if it's increasing or decreasing. It's going to be like this, guys. Kani
Yes,
ganing x go.
sir.
Go
We
go.
substitute, sir.
Somehow you are correct. Somehow you are correct, but there's something that we need to do. We cannot just right away substitute the values of these intervals here to the function. Um, Kaning x sub 1 guys and x sub 2, this is already the interval. So for this particular definition, it's x sub 1 comma x sub 2. That's the given interval. In other words, you have to have an interval for you to be able to know if the function is increasing or not. Let's try to solve it involving derivatives. So first, I'm going to solve the derivative of f of x equals x squared. Sorry. What's the derivative of x squared plus 2x? It's 2x plus 2. Tama? Question. Wala question so far? Wala. And then, after getting the derivative, guys, I'm gonna pick a value between this interval. I cannot use -3 and -1. The reason I can't use them because the interval uses the parentheses. Remember, if it's parentheses, the boundary values are not part of the specific interval. So we can only use those numbers in between of -3 and -1, unless the interval uses the bracket symbol or the brackets sign, I think, sign or symbol. So which number do you want to use that you can substitute here and this derivative here? We can use -2. So we can use -2, but this time, this -2, we're not going to use its original function. We're going to be using it in the interval, no, in the derivative function. So that's going to be f prime of -2 equals 2 times -2 plus 2. That's equal to -4 plus 2. We would get -2. Okay? Now, the conclusion here, guys, if the result of that derivative with the use of the specific number that you pick is less than 0, if it's less than 0, then the function is in decreasing, decreasing on the given interval. And the interval that I'm talking about is kaning interval -3, -1. So I'll repeat. If the value of the derivative, I'm talking about the first derivative, if the value of the first derivative, guys, after you choose a specific value from the interval is less than 0, that function is decreasing on that same interval, -3, -1. Later on, I'm going to show you the graphical or the graphic or the illustration of it, ganong decreasing siya. So with this idea, guys, how to make a definition? Sige, let's make a definition. Suppose, no? Suppose that a function, no, is defined, no, defined on an interval AC. So this is the premise. So suppose kaning function daw, kani specific nga function ang siya example. Kani siyang gimension nga function sa definition is all other functions that you can think of. So kani example lang siya. So what I'm trying to do, guys, nag-start yung example and then nag-formulate ko sa definition. Just so you know. Okay, scroll a bit. Okay. So, kana. So, suppose that a function is defined on interval AC. Kaning AC, guys, sa atong example, that's already the -3, -1. Okay? Ako lang use AC. You can use any other letter. You can use any other letter, guys. You can use B, B, G, or Boku Juice. What else? Love and lust. Something like that. You can use any letters, guys. Mga L1, L2, B1, B2, you can use any letter. Anyway, dami naman sa they can be replaced man. So suppose that a function is defined on an interval AC. We can say the graph is mag-start yung decreasing sa haka, decreasing mga example, decreasing if the f of c prime first derivative is less than 0 for all I'm just nagamit naman akong sino. Ako nalilisag x, kaya na naman din si diri, x lang. For all x nga na-belong ana nga interval AC. That's the first definition for this example. I'll repeat. In layman's terms, suppose you have a function, any type of function that is also defined on any interval AC. So kaning example here, our function is x squared plus 2x, and our interval is -3, -1. Okay? So if natin na nga situation, guys, natin na nga situation, ang graph di ay ana is said to be decreasing if inikuha ni mo sa first derivative of that function. So ang first derivative is maoni, kana siya, so x plus 2 from this specific function. If it's less than 0, how did I know the less than 0? Where did I get the x? That's when I pick a specific x from this interval. That's why muna kabutang diri nga for all x. Kani siya nga definition here, for all. Tanang x nga makuha nimo aning nga interval. So kanang x nga nabilong anang interval. So the x that I pick from our specific example nga nabilong aning nga interval nga -3, -1 is the x value -2. Okay? If it's less than 0, then yes, this case is good for or true to all functions. Amen. Okay, that's the good question. So this means to say if the function or the first derivative with the help of that x value that you pick in between of the given interval is less than 0, then the function is decreasing. Mauni siyang specific example for that definition. Okay? Now, let's do the other way around. Let's make use of another interval, and then let's have an interval nga increasing ang function. Sige, we're still gonna be using the same function, guys. F of x equals x squared plus 2x. Yeah, I'm gonna ask you, is this increasing or decreasing over the interval, this time -1, 5. No? Sige. The same steps will follow, guys. So you take the first derivative of that function, you pick a representative from the interval, you substitute that representative to the derivative of the function, and then solve. Try to see if it's greater than 0 or less than 0. So let's do this. So our derivative, guys, is f prime of x equals 2x plus 2. Amen? Amen. And then, sige, I want you to pick a number, please, between this interval. Any number. 3. So let's pick 3. 4. So Gian said 3, Quinn said 4. Sige, I need one more to break the to break it. 3 na lang, sir. Sige. Sige, I'm gonna choose 3. I hope you can still see the fonts or my kuan, ha. 2 times 3 plus 2, it's clearly showing us the result kay positive. So we have 6. We have 8. Agree? 8. And is this greater than 0 or less than 0? It is greater than 0. Then, if it's greater than 0, then the function is increasing on the given interval. And the interval that we are talking about is kaning interval. Of course, kaning bago ng interval. Di nakatulong interval before. So, in other words, if the first derivative and then the value of that first derivative using the function or using the value that you pick from the interval is greater than 0, in other words, that function is increasing on that specific interval. So how to make a definition that is similar to this, but you just have to edit some details of this one here. Anyone can type their answers. I'm going to write it here. So you go. So I want you to make your definition of an increasing function over a specific interval. I hope you guys received the attendance update na for the third quarter. So unsa man, what's gonna be our definition for an increasing function over an interval? Kruk, 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 kruk.
Sir, unsaon pag type sa element nga sign?
Ay, kuha na lang kanang ang kaning ino, kanang kuha na lang sa lang nga x is part of, x belongs to, kana instead of the element nga symbol saying x is part of. The graph is increasing. Okay, very good. The graph is increasing if the first derivative is greater than zero for all x being part of AC. Good job. So imo rang shortcut na. So according to kuan guys, according to Gian, this first statement will still be covered during a part here. So suppose kana siya, suppose that a function is defined. I hope you can still read my handwriting, guys. Ha? On an interval AC, ang second sentence lang ma-change. Not technically ma-usbog gini mo siya, pero na mga elements nga imong i-change. The graph is increasing this time if f prime of x this time is greater than 0 for all x part of AC. Actually, guys, these definition can sa book, and then I'm just trying to explain it to you ba kay if I think I have mentioned this before nga if kamo ra mo gyud mag-study sa book and then without proper guidance kay there's a tendency nga mapataka na lang sa book ba. So it's better nga ma-explain ang definition and what's really going on behind anong napormang definition. Okay, so questions so far. These two definitions, guys, what if we use zero, sir? That's a good question. Is that for number 2, Jarek? For the second interval, the -1, 5? Yes, you can still use 0. And if you're going to substitute 0 as your x here, you would still get +2, which is still greater than 0. So we can still say that the function is increasing on that same interval. So any rugged case in between of this interval, that's going to be true. That's why mo nagitawag nga for all x, meaning to say tanang x values nga nasud anang interval, we can tell nga kanang function is increasing if the first derivative is greater than 0 and it's decreasing if the first derivative is less than 0. O diba? So these two definitions, guys, would help us solve or tell if the function is increasing or decreasing without even graphing it. Kuha? Kay kung mag-unahon na ka-graphing manggod, guys, again, as I've mentioned earlier, it'll take like I don't know, depende sa inyo ha, 5 minutes or 7 minutes to tell if the function is increasing because you still have to assign values of x. After that, you solve for the value of y using the function, and then you form the ordered pairs, and then you plot the ordered pairs in the Cartesian plane. And then after that, you connect them, and then that's when the time that you can tell the function is increasing. Kaya na naka-illustration. But what if during the examination, you're not going to have like enough time for you to be able to complete the entire exam. So this is the help of derivative, and that's part of calculus. That's the beauty of calculus, guys. And this is discovered by Isaac Newton. So if namoy kalagot sa calculus, tell Isaac. questions so far for increasing and decreasing function? Wala. Sige, I'm gonna show you a graph of that function, guys. No, I'm gonna show you of that function. I'm gonna tell you nga sa kana gyud yung interval, the function is really increasing or decreasing. So take a look at this situation here. Kani siya nga function that I just show you, guys, is the graph of the function that we have earlier. So we had earlier. F of x equals x squared plus 2x. Mano siya ang graph sa function. Now, the first interval that we have, if I'm not mistaken, was -3, -1. So that's located here. Tama? Tama. So with that interval, guys, we're gonna try to see what's may behavior sa function sa kaning interval. And the function that I'm talking about is the graph. So gikan sa somewhere -3, mamay -3, then it's padong there is a -1. Go to dira. What can you tell? How do you describe the function? Should I call people? How would you describe the function? Let's hear from Rexel. Rexel Sanchez. For that interval, Rexel, -3, -1, how would you describe the function? Kaning violet nga ako ang gidraw-draw dira sa kilid.
Wait, sir. Magkuhan sa ka ako sa ikuan tanan.
No, actually, the answer is either increasing or decreasing.
It's decreasing, sir.
Very good. It's decreasing because it's going down to the right. So that's the answer earlier. Pod nga ang kana siya nga interval, kana siya nga interval nga -3, -1, the function is decreasing because of this definition that we just formulated earlier. Now, let's take a look at the second interval, -1, 5. So I'm gonna call other people, -1, 5. So somewhere 5 here. So this is the interval that we are going to focus on. Kana siya. And then the function behaves like this. So I'm gonna call, let's say, Adrian Valencia. Uni-chan. Adrian Valencia, I hope you are there. What can you tell or how can you describe the function if it's on that interval -1, 5? Crook, 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 crook. Okay, I'm gonna call other person. Maxine de Labahan. How would you describe it? Very good. Thank you so much for answering, Maxine. Yes, it is increasing. And that's what we have proven earlier using this definition that we just formulated. That the first derivative, if it's greater than 0, on that interval, the function is increasing. So question so far, guys, with respect to increasing and decreasing function. None so far? Okay, I hope everything is clear pa so far. Getting a point here, guys, is, that's the vertex of the parabola. The ordered pair that we have here is -1, -1. This is, or the x value here is what we call the critical value. We call it the critical value of the function. Because in other words, guys, every function, polynomial functions nga inani, kani mga points here, kana mga turning points nila, guys, is we call them critical points. Ang x value ana is we call it critical value. So kani siyang -1, 1, that's what we call critical points of the function. I hope you see the difference between critical points and critical value, okay? So not. Using the derivative as well, guys. So kanisha tong mentioned earlier, kanisha, this is determining if the function is increasing or decreasing with the help of derivative. Kani po siya, guys, to solve for the critical value or the turning point of the function, derivative can still be used as well. So let me just give you a definition. Definition. A number C, any number C which is part of the domain of the function is said to be a critical number or value of the function if either, wrong spelling, f prime of C equals 0 or f prime of C is undefined. So this is the actual definition of a critical value. In other words, guys, kanang number C no, any value na siya. So we use letter C to stand stand for critical value or critical value C. And then that C should belong to the domain of the function. When we say the domain of the function, these are the x values on which the function is defined. So that's why niya na ganiha ang kanang first element, which is the x, is the critical value of the function. Kay domain man na siya. That is going to be called a critical value if either aning duha or aning duha is true. So first, ang first derivative, guys, with the help of C should be equal to 0, and ang first derivative, guys, is undefined. So let's have one example, no? Kani. F of x equals x cubed minus 3x squared. Find the critical value or number. So this is very easy, guys. With the help of this definition, first thing first that you are going to do is to solve for the derivative of that function, of the given function. The derivative of f of x, ladies and gentlemen, is f of x prime equals 3x squared minus 6x. Agree? No violence reaction with that derivative. I should think that everyone agrees to that derivative, to that answer. Next, because of this situation here, either kani or kani, I'm gonna equate this one to 0. So this is going to be 0, and that's gonna be 3x squared minus 6x. Okay? From here on, I'm gonna solve for the value of x. So technically, guys, the manipulation is just simple algebra, right, good guys? I hope your algebra is as strong as possible, good guys, because calculus is just an algebra. Sige. I'm gonna factor out x. So we have x times 3x. I'm sorry. I'm gonna factor out 3x there, the greatest common factor. 3x. So we have x minus 2, right? And then equating these two factors to 0, product property, 3x equals 0, x minus 2 equals 0. Solving for x on both equations, we have x equals 0 and we have x equals 2. In other words, in this example, guys, for this function here, we have two critical values. These are x equals 0 and x equals 2. We can also tell nga, okay, kani siya nga function, sir, na siya duha ka book turning point. I'm gonna show it to you, ha? Sige, let me share my screen. My GeoGebra. I'm gonna erase this function first. So the function that I just gave you guys was the function equals x cubed minus 3x squared. There you go. Remember I said that there are two turning points, and these are the point, this one here and this one here. And in this point here, what is the x value? It was 0, right? the one that we just, I'm just gonna take a screenshot of this and then put this on our whiteboard here. Kani. Saan naman to? Share and then here. Sige. Take a look at here. The turning point of this function, or the graph first, the graph of this function, guys, is illustrated here, right? Okay. Huh? 1030 naman ko. 1030 naman ako no? Okay, so that's x cubed minus 3x squared. And then the critical value that we are able to solve, guys, we have two critical values. So this follows that the function, the original function has two turning points. And these are this turning point and also this one here. The point, the value of c in this point here is 0. The value of x, or yeah, critical value. Here one is the value of x here is 2. And that's what you see here, guys. X equals 0. That's what we have here. And x equals 2. That's what we have here. And if we're going to take a look here, this is negative 4. And this one here is 0, 0. Question so far for critical value? None so far? Okay. Let's have one more example for critical values, guys. What if f of x equals 2x over x squared minus 1. How about that? So first thing first, guys, is we're going to solve for the derivative. And since we have a quotient function, we're going to be using the quotient rule. So we have x squared minus 1 times the derivative of 2x, which is just equal to 2, minus 2x. The derivative of x squared minus 1 is 2x over x squared minus 1 squared. Follow? This becomes 2x squared minus 2 minus 4x squared over, that's going to be x squared minus 1 squared. Simplifying the numerator, guys, we would get what? Negative 2x squared minus 2 over x squared minus 1 squared. No? And then we're going to change this to 0. Because we're going to be solving for the x value, man. So doing cross multiplication, guys, we're going to cross multiply it. We would have 0 equals negative 2x squared minus 2. Tama? Transferring negative 2 on the other side, or the other one here, we would have 2x squared equals negative 2. Dividing both sides by 2, we would have what? X squared equals negative 1. No? Now, if we're going to take the square roots, someone is chatting. Okay. If we're going to take the square root, guys, this would become undefined. Kaya nga naman, when you take the square root of a negative number, it's undefined in the set of real numbers. It doesn't exist in reality. So in other words, at negative 1, that makes the derivative undefined. So kana ang siyang negative 1, guys, is also a critical value. Okay? That's also a critical value. Another thing, arita sa derivative, guys, kaning derivative, kanin siya. Unsa, aside from that nga, negative ang square root, guys, kano sa gani mahitabo nga ma-undefined ang function? Kano sa gani, go. Very good. The denominator becomes 0. So in other words, aside from this negative 1, guys, which would give us undefined because square root of a negative number is not defined in the set of real numbers. Another job that you still need to check, if it's in fraction form, you need to check if ang denominator, kano sa siya ma-0. That's when I asked earlier nga, nahitabo ma-0 ang denominator, kaya ma-undefined man siya. So aside from this answer, we should also have x squared minus 1 squared, equating this to 0. Okay? So that's going to be x squared minus 1 equals 0, getting the square root of both sides. x squared equals 1 and getting the square root of both sides, x equals positive negative 1. So in other words, doble na mong negative 1 nga critical value. So kausahon na nimo. So in other words, guys, your critical value for this item is x equals negative 1 and x equals positive 1. Question so far. Let me show you the graph of that function. Delete. Para makabaw dyan ba, asa siya nag-turn. 2x x squared minus 1.
So, sir, if our given is a fraction, we always have to check the denominator.
Yes.
We have to equate the denominator to 0
Very good.
and solve for x.
Yes, kay part man siya sa definition. It's either ma-zero ang derivative or ma-zero ang denominator. Sige. Wait sa ha. X1 and x negative 1. Okay. Saan ang 2x over x squared minus 1. Hindi lagi siya nag-show. Wait sa ha. Dapat pagamyan pa na ko siya para makita ang turning point niya. Hara guys. I hope you can still see this. Kana. So, ang critical value nga we're able to solve, guys, is negative 1 or positive 1. Okay, here. For this particular graph, guys, the negative 1 is here and the positive 1 is here. Tama? This item here, this value here, we're going to do a point. This is considered as critical value because why? This is where the function will never touch. Kanang, for example, baka na gining magkaduol ang function, guys. You might see nga magkaduol siya, pero di na sila mag-touch. That's considered as critical value. Because mao nang idea sa undefined. Diba? When we graph undefined function, magkaduol ka ana nga point but never touches that function. Kani ba? For example, no? F of x equals 2x over x plus 1. Kani siya nga function, guys, magkaduol na sa negative 1 but never touches negative 1. Kaya kung imo na equate ang denominator to 1 at to 0, you would get x equals negative 1, which ang function ma-undefined. So magkaduol kang negative 1, ma-undefined ang function, and that's what we see here. Makaduol kung negative 1, at the same time, new 1, the function becomes undefined. So that's why it is considered as a critical value. Okay? Questions so far for critical values? Sige. I'm gonna discuss asymptote. Very good. Asymptote are critical values as well. I'm gonna discuss about sani? I'm gonna discuss about relative maximum and relative minimum, absolute maximum and absolute minimum. But this discussion, guys, is just like a simple intuitive idea of what are they. So let me just choose a different pen. Sige. Ay, here we are. Sorry for that. Do you still see the whiteboard? No? Do you still see the whiteboard? Okay. All right. Sige. Let's say, for example, I have a function like this. No? When we say absolute max or absolute minimum, this is the lowest point of the function. Okay. I know that this can be considered as minimum. This is also minimum, and this is also minimum. But when we say absolute minimum, guys, it's the lowest point of the function. So this is what we call absolute minimum. Okay? Because that's the lowest point of the function. What do you call the other two minimums? These two minimums, guys, we call them relative minimum. In other words, these are minimum values of the function, but not lower than the lowest point of the function. You can say these are the minimum point of the function, but not lower than the lowest point of the function. Okay? There's also what we call an absolute maximum. So these points here, turning points, by the way, these turning points here we call maximum. The highest or the largest maximum is, we call it the absolute maximum. In other words, the highest point or the peakest points of the function. Kanang pinakatumoy ba? It's what we call absolute maximum. These two are still maximums. However, we call them relative maximum. Relative maximum. So these are high points of the function, but not higher than the highest point of the function. So that's the intuitive way of understanding relative and what we call this relative maximum and absolute maximum and the minimum as well. Sige. Ready for an actual example of Sunny? Of Sunny, uy, nawa na nung ko. Of optimization. Sige. We still have 30 minutes, so I think we would be able to cover this. A delivery company wants to come up with a package box that has a square base and excuse me, a volume of 40 feet cubed. What should be the dimension of the box with the least of material to be used? No? Question mark dapat. So this is one of the examples of optimization, guys. So you might be thinking, sir, this example is kind of like going towards engineering. Yes, this is the easiest one, man. But I have a lot of examples that would actually relate you to medical field. So just relax lang. At least kay mo sa pag-process pa. Okay. So I'm gonna explain it to you guys, but if you have any questions along the discussions, please let me know, ha? Okay. I will, as much as possible, I'm gonna do this like as straight as possible, gani, para wala yung mga questions. Kung may mga questions, just let me know. Then ako mag-throw questions sa inyo para dali na mahuman. Sige. Now, I know that the given volume of the box, guys, is 40 feet cubed. So I'm going to draw a box first. Okay. Box. It's a box. Yeah, that's a box. No. That's just... Wait. Weird na ako madrig box. No? There. Then, I think that's better. Sige. That's a box, I think. Close to a box. There. Okay. So, I know the volume of the box is 40 feet cube. So I know the volume is 40 feet cube. 40. Now, according to the problem, the box should have a square base. In other words, the base of the box should be a square. With that being said, the side of each of that base is equal to, the same by, what I'm trying to say is that the sides of the square base should be equal. So let's say, for example, this is x. I know that this is also x. Tama? Kay square base man daw siya. And the sides of a square are all equal. However, I don't know unsay height. So I'm just gonna use a letter y here for that height. Kaya wala mo kabaon sa. Hindi mention in the problem man. Okay, with that being said, the formula for the volume, guys, is given by length times width times height, right? So the length that I have is x, which is the same as the width. The height is, the same as the width. The height is equal to y. So I have a volume of x squared y. And because I know the value of volume, which is 40, I'm going to change it to 40 equals x squared y. So I have one model already. What I'm trying to do this one, guys, is I'm creating a model for me to start to solve for the derivative, okay? Because I have to have a model man. You notice nga dapat for us to be able to get the derivative, we should need to have a function. And that function that I'm talking about is the model. Sige. Now, the problem asked me or asked us, what should be the dimension of the box? In other words, if we're going to talk about dimensions, we're looking at the side length of each part of the box. So if one plywood, imong buhaton nga box, you still need 5 more plywoods para maporma siyang box. Do you agree? So for the base of the box, guys, I'm gonna notate as SA, or we can say surface area. So for the base of the box, the area for that base is equal to x squared. Tama? Kana usa ka plywood sa ubos. And then because I'm going to create a box, I would have another same plywood length or dimension sa babaw. So instead of writing x squared, I'm going to be writing 2x squared. Tama? And because I'm creating the box, I will be adding 4 more plywoods. And the areas of these plywoods are equivalent to x times y. And then upat man siya kabog, so I'm gonna multiply it by 4. So combining these two, these expression, kanisha o kanisha, would come up or would sum up to the total material needed for the box. Amen? Amen. But because our derivative deals with one variable only on the right side, so if you notice on the example, so we have our variable on the right side, kay usa ra gyud na siya. But the problem sa tuang situation here is that we have 2 variables. We have x and y. So we need to find ways na ma-express ni ang y in terms of x. With that being said, I would be able to rewrite this doing like this. 40 over x squared equals y, dividing both sides by x squared. So I would be able to substitute this y here to this y here. Para I would only have to consider x values na lang. 40 over x squared. No? Okay. I'm going to simplify this. I would have SA equals 2x squared plus 160 over x. Do you still follow? Okay. Mao niya akong kuha og derivative, guys. Kay diri man ko magkuha og optimal dimension. Remember, this is where the dimension of the box would be adjusted. Kay mao man ni imong pormahong box. Ang duha ka box sa ubos o babaw, ang upat ka box sa kilid sa mong box. Mo nang SA, mo nang 2x squared plus 4xy. So arita mag-derivative. Kaya diri ta magkuha og optimal material or minimum material nga magamit. So, with that being said, what's the derivative of this function here? So I'm just gonna use a different one, huh? I'm just gonna use a different color. So SA prime equals 4x squared minus 160 over x squared. Kamo na bahala og confirm sa derivative sa 160 over x. The derivative in any case is 160 over x squared using the quotient rule. Diretso lang ko. Kamo na bahala sa ang pag-show. You should get 160 over x squared negative. Okay. Next, to get the critical value. So, saan ito pag-solve sa critical value? We're going to be solving this in terms of 0. And then I will combine these two things here. So, we have x squared plus 4x cubed minus 160. No? And then I'm going to cross multiply it. So, 0 equals 4x cubed minus 160 degree. No? So not, what do you say, degree? We would get 4x cubed 160, tama? Dividing both sides by 4, we would have 40, and then cube root of 40, we would get this one here, 40. So that's your critical value. Pero wapa ka naman sa mong critical value because you still have another critical value because this is in fraction form. Remember, when we say critical value, that makes a denominator 0, undefined, and also the derivative equals 0. So the second critical value that you have is equal to 0. Because when you equate x squared to 0, the answer x is equal to 0. So you have two critical values. Are we good? Okay. So let's try to make a table, guys. Let's try to make a table. Interval. Not interval. Sunod kay the original function, which is kani 2x squared plus 160 over x. Sunod kay ang derivative, SA equals, let me just move a little bit to the left, 4x squared minus 160 over x squared. And then ang last kay ang interpretation. Ang conclusion. Okay. So how to form the interval, guys? Your interval, guys, mag-start sa imuhang critical values. So you start with x equals 0. So that's just the critical value. Next is from 0 to cube root of 40. Na. Sunod sa ka, x equals cube root of 40. And then another na sa interval, cube root of 40 until positive infinity. Naka-follow? Okay. I gets? Naka-follow pa, guys? Or kanang medyo kung ano siya, sir, kanang... Naka-follow pa so far? Sa solution? Yes, medyo taas na siya. Medyo taas na yun siya. Okay, sige. Next. Ang kani guys, ang kani siya here, kani nga part here. Ang imong supplyan ang nangadang second column is kani ra diri kani, mo rin imong supplyan. Kuha? Kani siya here, imong supplyan ang tanang rows. So you have to supply all rows. And then, kani, ang imong supplyan, guys, is later on na lang mo appear man na ka si supplyan nimo. Sige, let's start. Dita mo appear ani. So, unsa may, diba, remember, this is the, unsa ni? Sorry, my bad. Nawa na ko sa solution. If we're going to, my bad, kani dili din ni supplyan dapat. Ang supplyan is kani day dapat, kani, o kani. Sige, if imong x diri 0, walay kwenta, di ba? Kay ma-undefined man ni siya. Di ba? Kung imong x diri ba kay 0, ma-undefined ni. Undefined. Why gamit kayo. Sunod, if imong x here is cube root of 40, imong isabi siya sa x mo diri na kay answer. That's approximately equal to 70. Do you follow? Asa? Nganong? Sana? Nganong 4x cubed na after pag-equate sa... Asa ni guys? Kani? Asa ana? Asa na nga part? Maxine? Kani? Kani? Okay. Ako man nang i-combine kani siya. Do you know how to combine it? Sige ha. Unsa may LCD ani? Kaning 4x squared minus 160 over x squared. Di ba yung LCD kay x squared? X squared? X squared, di ba na 1 dira? X squared divided by 1, di ba x squared? Tama? Ay, dapat 4x cubed. Wait sa ha? Ay, sayop niya akong derivative, guys. My bad. Dapat 4x ani siya. Wala na 2 dira. No? Sakto? Sakto? Walay 4x na siya. So if imong kaon ang LCD kay x squared divided by 1, it's x squared, times 4x, that's gonna be 4x cubed. Minus, kay minus man na dira, x squared divided by x squared, 1 times 160, that's going to be 160. So mao na siya na dira. Okay na? Okay. Sige. So again, 17 ni guys, if we're going to substitute the x equals cube root of 40 sa x diri nga function. Sige. Sa kaning part guys, we're gonna be filling in the derivative. So if you notice, kung x mo kay 0, undefined gyapon siya sa useless, what ay idea ani. Di siya magamit. So, karon kay derivative man ni, you pick a number in between ani guys. In between aning interval. Representative. What do you think? We can choose 1. Masud man ang 1 dira, tama? I'm gonna be choosing 1, right? Alt H. So I'm gonna be choosing 1. If 1 akong x ani guys, nga 1 diri, ang answer ani going to be negative. So I'm just gonna take the value. I mean the sign lang. Kaya nga nung sign lang, kaya nga no, remember, kaya nga, if ang derivative of a function, magkuha kag value sa in between, kana no, isubstitute mo sa x or sa imuhang variable, if it's less than 0, pasabot ana, it's decreasing. Tama? What are values less than 0? Negatives. So, mo nang negative lang kung ikubutang. Kani here, kay 0 ni siya. If you're going to use cube root of 40 sa imong x diri guys, ma-0 ang resulta ana. I can guarantee you. So use your calculator or use your manual solution ana. Sunod, mag-pick kog number here. Let's say whole number lang 5. Inigbutang na kog 5 sa x diri guys, ang resulta ana positive na. Duha? Okay. So ang imo rang ano na ani guys, ang imo rang tagaan og bilian ni, ang katurang na ay mga dili undefined. So wala na kay labot ani. These are all undefined naman. You can just get rid of this. Okay. Unsa may behavior sa function if ang derivative first kay negative? Di ba it's decreasing? Tama? Unsa yung behavior sa function if ang first derivative is positive? Di ba it's increasing? Agree? Now, the problem, guys, tells us, the problem asks us nga, it says nga, asa naman to, unsa may dimension sa box nga gamay ra tag material nga magamit or to be used or with the least material to be used. If arita sa decreasing, guys, ang idea ani makagamay imong material, meaning to say kuwangon ang imong material. If ari sa increasing, guys, magkadaghan ng material, mean to say manubra sa imuhang material. We're looking at kanang sakto-sakto ra, pinaka-minimum nga material nga magamit, in which mauni siya nga value here. So ang idea ani guys kay relative, mo na diri ang relative minimum of the function. And that's the answer kani siya here. X should be equal to approximately 3.42. But since we are asked for the dimension, we need to know unsa may value sa y, sir, if x is equal to 3.42. So if x is equal to 3.42, guys, you just have to substitute that to x here para ma-solve nimo si y. 40 over 3.42 squared, your y is equal to 3.42 as well. So in other words, the dimension of the box is 3.42 by 3.42 by 3.42 feet. If we're going to multiply those 3.42, you would get 40. Approximately 40.001. So again, how did I know nga it's relative minimum? So take a look at this one, guys. Ha? Kani siya, guys, decreasing. Makaibaw kita nga padung pa na siya sa ubos. So we have an idea nga napag siya mas ubos pag yun sa minimum. Kaya magpadong, decreasing man siya. Kani siya, guys, kani increasing, magpadong siya saka. We know nga napag siya mas taas pa sa taas nga makita nimo whatever. Kung asa na ba dapita sa particular function. So ang katong other taas ug mubo, we call them relative minimum or relative maximum. And how did I know it's minimum? Because it talks about the least dimension. If it talks about the greatest dimension, mausab ang function, this time, ang interpretation na is relative maximum na, dili na minimum. Question so far? I hope visible pa siya ninyo, guys. Is it still visible?
Yes, sir.
Dara ang final answer, guys. Question so far, it's already 10:27. X is 3.42 and y is equal to 3.42. So we are able to confirm nga, okay, it's a square box di ay, sir. Same ang base, same pod ang kanang magbarog nga plywood, same pod ilahang length and width. Sakto? Nakalisod na siya, guys. Yes, taas siya, guys. It is recorded, guys. It is recorded. Yeah, another challenge was aside sa taas siya, guys, is you have to be familiar with the formulas nga you have already covered before. Like, how come nga, diba, from the given item, wala matagihatag nga function here. How come nga na-forma ni siya and how come nga na-forma ni siya? Kani siya is the formula for the volume because it's given in the problem. How come na-forma ni siya? Guys, this is, I believe, if wala ni siya na-discuss, you have to consider this sa yung junior high school nga. This is the surface area of a box. Okay? Surface area na siya sa box. So, that's just for box problem. Pwede man sa tamuhimog cylinder nga problem. No? Pwede sa tamuhimo og cone nga problem. O, di ba? It gets more interesting. Kaya ra lagi na, guys. Anyway, question so far, it's already 10:29.
Sir, nako'y na-observe, sir ba?
Yep.
Pwede unta nimo i-assume nga ang height kay the same ra.
Yes, that's actually the thing. But
Ang
that's
hapon, sir. Ang
that's
kanang yang kilid square.
that's actually after we do the solution na. Pero what if wala pa ta kahibaw sa solution?
Taas kayo siya.
Wala na og same kay the fact man good is that it was not specifically mentioned in the problem nga ang height mao ni siya dapat. The clue that was given to us is only ang square base ug ang volume sa box.
Sige, sir.
Sige. I'm gonna send more examples, guys, to work on. Dili siya assignment task, so just a practice items. For this week, guys, I want you to work with the 2 performance tasks. I hope mapasa nyo by the end of this week, 16. Is it 16? Yeah, I think so. It's 16. Para makakompute na ko sa inyong grado. Kaya mauna naman to ang last nga akong ipa-work ninyo. Questions so far?
Wala na on my end, sir.
Wala na. How about the other guys? Other pips? Okay, that's it. Thank you so much, guys. I'm gonna be uploading this item or this video or recording sa tuang Shello. Okay? Take care, guys, and have a great day.
Bye, sir.
Goodbye. Thank you, sir.
Thank you, sir.
Bye, sir. Thank you.
And bye. Thank you, sir.
I'm gonna
Goodbye. Thank you,
stop
sir.
sharing. Okay, take care, guys. Stop.